Okay, so the next step is to align the imagery with a reference dataset. Now I can go directly to the image alignment, the coarse image alignment step, and point to my reference file. However, what is preferable is to spend maybe 5-10 minutes to collect ground control points in the four corners of the project. So let me explain to you what I mean by that. So let's open up Ortho Engine once again. And we will load up our fiducial project file. And we'll go to the GCP Collection dropdown. And if I open up the display project overview, everything looks quite nice. All of the images or footprints are displaying nicely. And what I want to do is I want to collect a ground control point on this image, which is 88. So let me just jot that down. So image 88 is the top left. Then it looks like image 92 is my top right. Image 24 is my bottom right, and image 19 is my bottom left. I just made a note of that so that I can open up those images in a minute. So what I'll do now is I will go to the manual GCP collection window. You can see I get a list of the images, which is why it was important that I wrote those down. So if I go to my, I'll start with my top left, so the number 88. I'll open up that image. And in terms of the ground control source, I will use a geocoded image. And I'll go to my reference folder and I'll open up my reference image. So I can choose all three bands if I want. In this case, it's a color image. And I'll just zoom out here on the overall image mosaic. And you can see that I have the footprint of where my image is roughly located, which is nice and handy. And let me just try to find something that looks familiar in both images. So and also will serve as a good ground control point. So if I zoom out to the overview of this one, maybe down here in this bay I'll find a road or something that looks somewhat familiar between the two images. Now of course the time separation between these two data sets is quite large, so there'll be quite a few changes. So let me just roughly position this point here and this point here. And I'll go use point and use point, and you can see that it has collected the information. Now I can also refer to an elevation model, so I'll choose my model here and I'll extract the elevation at that location, and then I'll accept the point, and that will give me the rough positional accuracy at this point. So that's for one image, so I'll close this one down. And the next thing I'll do is I will open up the top right, so 92. Once again, I'll do the same thing. I'll zoom out here. Should give me the footprint of my image. Sometimes natural features are best to use for historical air photos, things like lakes and rivers. They tend to change less if you can find something that's common on both images. So let me just zoom into this natural feature here. This looks like a lake that's been here for many years. And here we have an island. So these aren't the best points to use, but let me just go ahead and use them anyway. So I'll roughly position my cursor here at the bottom of the island, use the point, extract the elevation and accept it, and I'll close this one down. Next I'm going to go to image 24, which is my bottom right image, and I'll just zoom out here, and I'll zoom out on the reference image. So I'm down in here. Looks like the landscape has changed quite a bit, but I think this road has actually been there for quite some time. So let's go take a look in here. Okay, so here we have the road intersection, which is probably changed a little bit, but let's go ahead and actually this house looks like it's been here probably since 1967. So let's pick the outside of the driveway on this house, maybe roughly over here, something like that. Use that point, extract the elevation and accept it, and we will go to our last image, which is number 19. So let me open that one, and we'll zoom out here. Alright, so image 19, looks like there's some lake features that maybe we can work with here. And we'll try to pick something that hopefully hasn't changed too much. Maybe just the intersection of this road. Oh, that's a new road. You can see the challenges of working with historical air photos sometimes. So let's just pick the top part of this feature along the edge of the lake. And we'll use that, extract the elevation, and accept the point. So again, it doesn't have to be super precise. Really what you're trying to do here is you're just trying to give information to the system to roughly position the features in the right location. We can always reject these points down the road. What we're doing is we're just helping the system to roughly position the images to have a good model. So we'll close this down. We'll close our windows, our manual GCP collection. So you can see that took a few minutes, but this is a good time investment down the road. And we'll save our project, which I just did there, and we'll move on to the next step, which is going to be the alignment. Okay, so let's open up the alignment panel, and the input data folder is the location of our ingest project. So I'm going to point to this folder here. This has all of the model information that we've been able to calculate so far relating to our project. We'll point to the reference elevation model. So if I go to my reference folder, this is the file that I want to use. So I'm going to just go there and pick the elevation model. And the reference file, as you recall, is this JPEG 2000 file. Now, you probably notice some compression on the file. We had to compress the image down to be able to work with Udemy. So hopefully that doesn't cause any problems, but here we go. And the next thing we need to do is to specify where we want to create this alignment step. So we'll create a folder here called Coarse Align, and we'll put that in the output data folder, and we'll just check all of our parameters. Now I'm leaving all of the parameters as a default at the moment, and we can play with these later on, but let's do a first attempt here with the default parameters. So essentially the system right now is searching for both ground control points in terms of the images themselves and the reference data set underneath, and it's also looking for tie points, so common features in the overlapping images. And our goal is to create a block bundle or an adjusted model for all of the data to be corrected in one single data set. And that's really how we're going to achieve a high level of accuracy, is by leveraging all of the images together into a complete model. Okay, so as you can see, the complete process is finished. If I scroll up here all the way to the top, the first part of the process was the automatic GCP collection. So it went through each image and collected GCPs using the reference image. You can see 2 of 18 here. And once it got through that, it collected tie points for all of the images. So all together, this whole process took roughly 20 minutes. So that's for the coarse alignment. And the next step will be to inspect the results of the coarse alignment and to see if there's any problem areas.